Hi, since we're now done with the rendering, we can tackle some small things that we left behind for later. First, we can start with being able to handle resizing of the window. We can detect if a window resize has happened through Vulkan. Going to the begin frame here, the acquire next image call here we will return a result. We can check if this result is a special error called out of date. This essentially means that the swap chain no longer matches the surface. In that case, we will recreate the swap chain. And we also need to get out of this function. Essentially, we will not be rendering this frame. We also need to move the reset fences just before the begin command. I will make the function return true or false, indicating if the frame has begun. Now, since we're checking for this result, we might as well check if it was not a success. And we can check one more valid state called suboptimal. In the suboptimal state, we don't need to recreate the swap chain, but it is not an issue. Now, I will correct the begin frame signature, and I will copy this code to recreate the swap chain. I go on to the header and I introduce the recreate swap chain method. I also introduce a new method called cleanup swap chain. And back to the CPP file, we can now implement both of these. The cleanup swap chain will be easy. We need to call a few things from the destructor. So I start by checking if the logical device was created. Then I copy the frame buffer destruction and I delete it from the destructor. I also cut the image views destruction and I paste it in the new method. And finally, I cut the swap chain destruction, again pasting it in the new cleanup swap chain. We can now call this at the start of the destructor. Now for the recreation, we need to wait for all rendering to finish. Then we clean up the swap chain. And also in the destructor, we actually need to move this call for cleaning up the swap chain. It needs to happen after the device is idle. And finally, we can call some functions from the initialize Vulkan method. We need to create a new swap chain, new image views, and new frame buffers. Also, at the end of a frame, we can get a result when presenting to the surface. Since all these calls are asynchronous, we can check for the same status when the frame is finished. If it was out of date or suboptimal, we will recreate the swap chain at the end of rendering. Else we need an error, so we throw an exception. Now in the main loop, we will only render the triangle at the end of frame. If the begin frame was a success, we also need to allow the window to be resizable. So we navigate to the window constructor and comment out this line here. I build and run the project. Now with this window you can see I can now resize it. And it doesn't give any errors and it seems to handle it well. So we close this. Actually, I forgot to talk about one special state of resizing. A window can minimize as well. In the case of being minimized, you have the window being resized to 0 by 0. So if I minimize it, you'll see all these errors now. To fix this, I can go to the recreate swap chain from this lesson. And here, if the window for get frame buffer size is equal to 0 by 0, we'll just wait for event. This essentially blocks the CPU until the frame buffer size changes. You can also have another solution if you don't want to block the application. You can delete the old swap chain and just return from the begin frame method if there is no swap chain. For the purpose of being short, I will not do this, but you can take it as a homework.